Good morning. We are looking at 1.5, and we are looking at inverse functions. In other words, how do inverse operations generate inverse functions? So immediately I see two kind of key vocab words. So the first is inverse operations. You know inverse operations, you maybe just haven't assigned that language to them before. But inverse operations are opposite operations that undo one another. Some popular inverse operations: plus, minus, multiply, divide, sine, sine inverse. That's something maybe you remember from geometry. Okay. And we use those inverse operations to build or create inverse functions. And inverse functions are two functions that use inverse operations to undo one another. Okay. The notation we use is if our original function is f of x, the inverse function gets that little -1, kind of like in sine up there, that little -1 to show that's the inverse. Okay. So let's take a second and actually talk about how do we come up with these inverse functions? What does that even mean? What does that look like? So here we go, finding an inverse. The language I like to use is switch and solve. So we're going to build some two-column notes here, and we are going to look at an example. So first of all, I'm starting with f of x equals 3x squared minus 5. The first thing we're going to do is we're going to change f of x into y. A lot easier to work in this equation if we change it to y. Remember, the f in f of x just helps us distinguish between different functions. If every function was written with y equals y equals y equals, there's no way to clarify which one you're talking about. So we give them names. So anyway, we change it to y. Then we switch x and y. Now, if we were going to switch roles, teacher and student, you would come to my classroom and you would sit in my chair, and I would go to your house and sit on your comfy couch and eat snacks, right? I wouldn't bring anything with me. I'd leave everything right here, and you'd leave all your stuff right there, ready for me to have my snacks. So with that being said, notice I did not bring the 3 that was on the x, and I did not bring the squared that was on the x. I just swapped x and y. Okay. So with that being said, now my job is to solve for y. So I want to get y by itself. And here's how I'm going to do it. I'm going to add 5 to both sides. My job is to isolate y. Then I'm going to divide both sides by 3. Whoa, my bad. That was super weird. Why? And then I'm going to finish by undoing squared with a square root. So here's where we've landed. X plus 5 over 3, the square root of that, equals y. But we started with f of x, so we are going to finish by changing it back to f of x notation. Okay? So that's a problem that we just worked through. Now what we're going to do is we are going to just process what we did. So the first thing we did was we changed f of x to y, because we said y was easier to work with in the equation. It gave us a variable instead of the function name. And then we switched x and y. Remember, we didn't bring any of their baggage with them. We just flipped the letters around, kind of like Freaky Friday, if you've ever seen that movie. So switch, that was one key word in our notes up above. The other one was solve, because the next part of the process was we used inverse operations, plus to cancel a minus, squared or square root to cancel squared. And then that essentially got us to here. And then we finish by writing f inverse of x. Right, that was our final step once we had done all the work. So that's the process. We switch it and we solve it. One other thing I want to show you real quick is this. I want to show you how to check inverses using composition. Okay. If f of g of x equals x and g of f of x equals x, then f and g are inverses. So if you fog it and you goff it, and they're both x, they're inverses. So let's check this out. Function number one is f of x equals the square root of x plus 9. G of x equals x squared minus 9. Okay. The first thing I have to check is the fog. Fog x. Remember, fog means f of g of x. And that means that g of x, that function, is going into f. So wherever there was an x in the f function, I'm putting parentheses. And inside those parentheses, x squared minus 9 goes. There's no distributive property necessary, so it can essentially probably just drop those parentheses. But the 9's cancel. I get the square root of x squared, and that just gives me x. So far, so good. Let's check the other side to be safe. Now I have to goff it. G of f of x. F of x this time is now the square root. And that is going to live inside g. So that square root pops into where I had those parentheses. The squared and the square root cancel, and I'm left with x plus 9 with a minus mine in the back. Plus minus 9 cancels, and we get x again. This means f and g are inverses. Yay. A lot of notes there. Go through them. You only have notes today, so take good notes and then ask questions if you get stuck.